Some slides here that get technical, but the intent of this presentation is not to make you an expert on all things redox, right? The intent is to show you what the team is working on and that we have experts who are advancing the science of redox. Again, it is not expected that you can go and teach this to those who you are introducing the technology. Instead, the intent of this presentation is to build your conviction behind this technology and its ability to change lives. So redox, what is redox? Every one of us has heard this question many, many times. Redox is a contraction or an abbreviation of two words, reduction and oxidation. Good, good. Reduction and oxidation. Everything on this planet living depends on reduction and oxidation. I'd like to leave this quote with you before we proceed. Life is nothing but electrons looking for a place to rest. The second part of that quote is the most important part. Looking for a place to rest. What is an electron? An electron is an extremely small, negatively charged particle. There's a ton of energy associated with these electrons. They're able to contain a lot of energy. Redox is the process of electron transfer. What do we mean by electron transfer? We mean an electron is transferred from one atom or molecule to another. Okay, that is the process of electron transfer. In other fields of chemistry, electrons come together to form bonds and are shared. In redox chemistry, electrons are not shared, but they are transferred. Okay? Now, electron transfer can be thought of as the transfer of energy. So redox is reduction and oxidation, the transfer of electrons, and if electrons possess energy, then redox can very simply be thought of as a transfer of energy. Okay, does that make sense to everybody? I'm seeing lots of nodding. Good. Who has seen this example before? Those of you that train the trainer can raise your hands. No cheating though. If I ask questions, you guys know the answers already. Let other people answer. I heard the 90% answer a lot already. Okay. Imagine we have a ball on top of a hill. What happens if I give a little push to that ball? Rolls down the hill, right? We know that intuitively. We know it naturally. We don't have to think about it. When I push a ball down the hill, it rolls down the hill. My question to you is why? Why does the ball roll down the hill? Gravity is the force that acts on the ball pulling it down the hill, right? Here's my follow-up question to you. Why does gravity pull the ball down the hill instead of push the ball up the hill? What is it special about gravity that makes it pull the ball down the hill?
No, the energy of gravity is pulling down.
Looking for rest, right? What does the ball possess at the top of the hill that it no longer possesses at the bottom of the hill? Energy, there it is, energy. Everybody was sitting at the edge of their seat waiting to say it. In this presentation, there is a theme, okay? I'm gonna give you a little secret. If I ask a question, 90% of the time, the answer is energy.
Energy, yeah.
Okay? So, at the top of the hill, the ball possesses a type of energy. What kind of energy does it possess?
Kinetic.
Potential energy, right? You guys learned well yesterday. That's great. Potential energy. There are two types of energy in Newtonian physics. There's potential and there's kinetic. Kinetic energy is the energy of motion. Potential is the energy that is stored, whether that be gravitational, magnetic, electrical. There are types of stored energy, and that is called potential energy. Okay? This ball had potential energy, but the moment I gave it a shove, it wanted to release that energy. Why? Looking for a place to rest, right? Remember this quote? Life is nothing but electrons looking for a place to rest. But you may say, Hunter, we're talking about a ball here, right? That says electrons. Let me cue you in on a secret. In the study of thermodynamics, there is a concept called entropy. Entropy is a law that states everything that is made of matter, atoms and molecules, in the universe is looking for its lowest energy state possible. Everything in the universe is looking for the lowest energy state possible, looking for a place to rest. So when that ball is given the opportunity to roll down the hill, what happens? It looks for its place to rest and it rolls down the hill. So this concept of entropy is going to lead our discussion into why electrons transfer. Okay. When I talk about electron transfer in the next few slides and you begin to get confused because we get technical, first remember, you do not have to be able to explain this. There is no exam afterwards. Second, think about the ball rolling down the hill. It is a very good analogy for this concept of electron transfer. So, on the right, on the left, we have an atom that is being oxidized or losing an electron. On the right, we have an atom that is gaining an electron or being reduced. That electron transfers from left to right. Why does the electron transfer? Think about the ball. Looking for a place to rest. Perfect. I would have also accepted energy. High energy on the left, low energy on the right. What does the electron do? Transfers, looking for a place to rest. Okay? Now, here is the key tying redox to what we talked about with cell signaling at the very beginning. Another principle in thermodynamics states that energy cannot be created nor destroyed. Who's heard that before? Okay, few of you. If energy cannot be created or destroyed, merely transferred, if the electron here possesses a lot of energy, and then after it transfers, it possesses very little energy, where did that energy go? To the surroundings. You guys are on it today. You guys know. To the surroundings. What if you could cause that transfer to happen inside your cells? What are the surroundings now? Your cells. What do your cells need to signal and communicate? Energy. 90% energy. Cell signaling and communication requires energy. If you can deliver energy through electron transfer, through redox signaling molecules, you can improve cellular function because you improve cellular communication and signaling. I'm not going to go into this extremely technical graph here today to the depth we did yesterday. But here is the process that we use to manufacture the product. We start with a super pure sodium chloride, and we dissolve that into an ultra pure water. We then put energy into the system of that saline. That increase in energy helps to form bonds that make redox signaling molecules. When redox signaling molecules enter your cells, those bonds break, and that energy is released to your cell to help it signal and communicate. You'll notice there, I have it labeled energy, but in the field of redox chemistry, we call energy potential, redox potential. At the beginning, we talked about the brand promise of ASEA, we power potential. and I kind of told my story as to why I believe that we power human potential. But there's a second meaning to that brand promise. Yes, we power your potential as an individual to build a team and be a force for good in the world. But we also, in a very literal way, when we say we power potential, we mean we power potential of your cells to signal and communicate. Now, tiny high energy molecules, because they're tiny, they can be absorbed. What does that mean? These molecules are so small they can pass right through the cell membrane into the inside of the cell. Once absorbed, these molecules act like an on-off switch, turning on cell signaling and communication. Once a cell signals to the cells around it, those cells signal to the cells around them, beginning what we call the cascade or domino effect. You guys can see what's going to happen here. It's going to spread throughout the entire group of cells, right? This is theory at this point. We're doing research to provide some data. But I believe this cascade happens differently in everybody. We are all very biodiverse as users of ASEA. We have different cell signals, different cellular makeups, different genes, different DNA. And so this cascade happens differently in each one of us. I believe that proposes and suggests a reason why ASEA affects each one of us differently. This cascade and domino effect contributes to our resilience to stress and overall wellness. I like to use this example of the balance or seesaw. I said earlier today that we are exposed to stress in today's modern time thousands, if not millions of times per day. When we're exposed to stress, we are knocked off of balance. We call it redox homeostasis, is the fancy word for redox balance. In order for me to maintain my health and wellness, I need to be in the center. But again, I'm knocked off balance thousands of times per day with different forms of stress. So I'm now knocked off center. What do I need to do in order to get back to center? I must respond to that stress and get back to center. What does your body use to respond to stress? Energy. In the form of what? Redox signaling molecules. Your body is making redox signaling molecules in the mitochondria of your cells every day. All of us make redox signaling molecules. The problem is we don't make enough of them. We are exposed to too much stress to be able to have enough redox signaling molecules to help us respond and get back to center as often as we need. Your redox signaling molecules and your ability to respond to stress is perhaps the single most important attribute that you have as a human being to maintain your health and wellness. Let me say that again because I think it's extremely important. Perhaps the single most important tool that your body has to maintain its health and wellness is its ability to respond to stress and get back to center. Now, you're never here permanently. You're exposed to stress far too often to stay in the center. So you must respond constantly and get back into center. This is why redox signaling molecules and cell signaling and communication is so important. It is your very ability to respond to stress that is responsible for maintaining your health and your wellness. I'd like to talk about the Torrey Lab study of 2017 briefly if I could. The Torrey Lab study